So now we're going to talk about end behavior of polynomial functions, and there's actually 4 different scenarios that we're going to cover today. So to start us off, we're actually going to look at the first 2 scenarios together, and that's if we have a degree that is even and a leading coefficient that's positive, and I give you an example right below it that we're going to talk about in just a minute. And we're also going to talk about what if we have a polynomial function with an even degree but with a negative leading coefficient. And I also gave you an example right below of something to think about as we're starting to deal with these polynomial functions and end behavior. So let's go back to the first scenario first. If you have an even degree and a leading coefficient that's positive, I want you to kind of think of the example of f of x is equal to x squared, okay? Because they're going to have the same type of trends as we get going. So if I just plotted what a quadratic looks like, the parent function of the quadratic, 1 squared is 1, 2 squared is 4. So if I just kind of sketch a graph of what that quadratic would look like with a positive leading coefficient, I'm going to have a parabola. And in this particular case, I know that my y, or f of x, is my vertical distance, or my vertical axis, and my x-axis is my horizontal distance. Now, in each of these cases, I have 4 quadrants, right? And in quadrant 1, I have positive x values, positive y values. Quadrant 2 gives me negative x values, positive y values. Quadrant 3 is always negative x values, negative y values. And quadrant 4 is positive x, negative y. And so to start off, it's kind of an easier thing if we look at where the arrows are pointing. So I'm just going to kind of circle where my arrows are pointing, because end behavior is all about those arrows, where those arrows are going to take our overall graph over extended amount of time. So looking at this arrow, starting off to the left, we read from left to right. We're going to start with the arrow from left to right. And this arrow is in the positive y region. So picture your y region being like the top region and the bottom region. So this arrow is in the positive y region, but it's also in the negative x region. Okay, so you've got this arrow it grows and grows and gets bigger and bigger towards the y. You're also getting wider and bigger towards your negative x. Okay, so in this case, as f of x approaches positive infinity, as it continues to grow bigger and bigger positive, I'm in the negative x region. My other arrow that I have is also going in the positive infinity region for your y. It's growing, and it's getting bigger and bigger going up. But in this case, this arrow is in the positive x region. So as this arrow gets bigger and bigger moving upward, it's also getting bigger and bigger moving outward to the right in the positive infinity x direction. So the way we would read the end behavior for this particular graph, and that's the case if it's ever even and your leading coefficient is positive, you will always have your arrows pointing in the same direction, and they're going to be pointing upward. So in this particular case, as your f of x, or essentially your y, gets bigger in the positive infinity region, so it's getting bigger going upward, your x is going to approach both negative infinity, because it's getting wider to the left, and positive infinity, because it's getting wider to the right. Your other scenario is if you have an even degree but your leading coefficient is negative. So in this case, if I were to plot, I have negative x to the 4th power. So if I were to plot this particular graph, 1 to the 4th power is 1, 2 to the 4th power is 16, so this is going to be way down here. So it's kind of like a parabola, but it's more squished in this particular case. Now in this case, our f of x, we have our arrows pointing in the same direction. So if it's even, we know that no matter what, degree even means our arrows are going to be pointing in the same direction. And in this case, they're both pointing down. So we know that f of x, the only option for f of x is it's going in the negative y, negative infinity region or negative infinity direction.